So for some reason my video cut out, so I'm gonna, and I was still talking, so I'm gonna pick up where I left off. So I told you guys that this was the answer, but what I was trying to get my point across for the next thing is you can always check your work by simply taking your 5y and distributing it to what's in your parentheses to see if you're back to what you had at the beginning. So 5y times 2y, that would be 10y squared, and then 5y times 3 would be 15y. Now that's something that you could do in your head. You don't have to write that down, but I did want to show you that you can take this and redistribute it to see that you have the same problem that you had in the beginning, and that's how you know that this is the correct answer. And I would encourage you to do that just even mentally. You don't have to write it down, but if you do it quickly in your head and see that you end up with what you started with, that's how that you know your answer is correct. So it's a great tool to make sure that you're doing it right. Okay, so let's take a look at the next one. We have 18x squared, and I'm going to break that down. Now again, you can do the factor tree. You can do what I did where you do the upside down division, right? So 2 would go into 18 9 times, and 9 can be broken down into 3 times 3. Some of you guys might be really good at doing that mentally, and so you might want to jump right into the step that I'm at right now where I'm breaking it down. So I have 2 times 3 times 3, and then x squared would break down into x times x. And I'm going to do the same thing for 12x cubed. Again, if you can do this mentally, that's great. So I have 12. It's even, so it's divisible by 2. And then I'm going to break down the 6, and that breaks down into 2 times 3. So I have 2 times 2 times 3, and then x cubed means I have 3 x's being multiplied together. So again, I'm looking for what do they have in common? Well, they have a pair of 2's in common. They have a pair of 3's in common. They have a pair of x's in common. And then we have another pair of x's in common. So what would that GCF be? Well, we would have 2 times 3, which is 6, and x times x, which is x squared. But that's not where we're going to stop working, because now we're going to take that 6x squared out. We're dividing it from each term. So we're going to start with the 18x squared. If I divide 18x squared by 6x squared, the only thing that I have left is a 3. Then I'm going to put the minus sign down, and now I'm going to go to the 12x cubed, and again I'm going to divide it by the 6x squared, and if I look and see that the 2, the 3, the x, and the x have already been taken out, that leaves us with a 2 and an x, and that multiplies into 2x. So this is our answer, but let's just real quick go over that together. What would happen if we distributed this? Well, 6x squared times 3 is 18x squared. Perfect so far. Then we would bring down our minus sign. Then we would do 6x squared times 2x, which would be 12x cubed. So we do have the correct answer. All right, so let's do the same thing with 28a to the 4th. Again, if you need to break that down on the side, that's fine. I know that 28 breaks down into 2 times 2 times 7, and then a to the 4th breaks down into 4 a's being multiplied together. Now I'm going to do the same thing with 42a squared. 42 is going to break down into 2 times 3 times 7, and then a squared breaks down into a times a. So let's look at see what they have in common. We have a pair of 2's. We have a pair of 7's. We have a pair of a's. And then we have one more pair of a's. So our GCF, 2 times 7 is 14. A times a is a squared. So we're going to take out 14a squared. Again, we're doing the distributive property backwards. So what's left when we take it out of 28a to the 4th? Well, we're left with a 2 and 2 a's. So that turns into 2a squared. Then we've got the minus sign. And then what's left when we take it out of 42a squared? All that's left is the 3. Again, you can distribute that back into it and see that it does work out appropriately. All right, so let's keep going. Let's take a look at this next one. We have 28a squared b. All right, well, we just broke down 28 a minute ago. It was 2 times 2 times 7. A squared means we have 2 a's, and then we have a single b. Then we're going to break down 56a b c squared. All right, 56 is going to break down into 2 times 2 times 2 times 7. Then we have a single a single b, and 2 c's. So let's see what we have in common. We have a pair of 2's, another pair of 2's, pair of 7's, pair of a's, pair of b's, and that's all that's in common. So 2 times 2 times 7 is 28, and then a times b is just ab. So we're going to take 28ab out. Let's see what we would have left. From the first term, all that's left is a single a. Then we're going to have a plus sign. And then from the second one, we have 2 and 2 c's left. So we're left with 2c squared. So these should be pretty easy problems. Let's take a look at number 5. We have 20x cubed y. So 20 would break down 2 times 2 times 5. X cubed means we're multiplying 3 x's, and then we have a single y. Then we have 24x squared y cubed. So 24 would break down 2 times 2 times 2 times 3. X squared would be multiplying 2 x's, and y cubed is multiplying 3 y's. And let's take a look at what they have in common. I've got a pair of 2's, another pair of 2's, and that's it for the numbers. Then I have 2 x's in common and 1 y in common. So let's see what our GCF would be. 2 times 2 is 4. X times x is x squared, and then we have a single y. So we're going to take 4x squared y out, and in parentheses we're going to write down what's left. When we took it from the first term, we're left with a 5 and an x. Then I'm going to bring down my minus sign. And then when we take it out of the second term, we're left with a 2 and a 3, which turns into 6. And then we're left with 2 y's, which is going to turn into y squared. And that would be our final answer. All right, so number 6 and number 7 are a little different because they have 3 terms. So we're going to be taking or finding a GCF from all 3 of those. So we have 16f g squared. We have 24g squared h. And we have 40g squared. All right, so let's break these down. 16 is going to break down into 2 times 2 times 2 times 2. Then we have 1f and 2 g's. 24 is going to break down into 2 times 2 times 2 times 3. And then we're going to have 2 g's and an h. And then 40 is going to break down into 2 times 2 times 2 times 5. And then we're going to have 2 g's. So what are some things that they all 3 have in common? Well, let's see. We have a group of 2's, another group of 2's, and a third group of 2's. And then we have a group of g's and another group of g's. So what would the greatest common factor be? 2 times 2 times 2 is 8, and g times g is g squared. So we're going to take out 8g squared. When we take it out of the 16f g squared, we're left with a 2 and an f. Then I'm going to bring down the minus sign for the middle term. When we take it out of the 24g squared h, we're going to be left with a 3 and an h. Then we're going to bring down the plus sign. And lastly, when we take it out of the 40g squared, all we're left with is the 5. And so that would be our answer for number 6. All right, so let's try number 7 together. We have 6k cubed m. Then we have 14k squared m squared. And then we have 4k cubed m cubed. So let's break those down. The first one is going to break down into 2 times 3. Then we're going to have 3 k's and an m. All right, next 14 breaks down into 2 times 7. Then we have 2 k's and 2 m's. And then this last one is going to break down into 2 times 2, and then 3 k's and 3 m's. So what's something that all 3 of them have in common? We have a group of 2's, a group of k's, another group of k's, not enough to make a third group because the middle one no longer has k's. Then we have a group of m's, and then that's it. So our GCF here is 2k squared m. All right, so 2k squared m. And now we're going to put in parentheses everything that's left. So from the first term, we're left with a 3 and a k. Then we're going to bring down the plus sign for the middle term. From the middle term, we're left with a 7 and an m. Then we're going to bring down the minus sign for the last term. And from the last term, we're left with a 2, a k, and 2 m's. So 2k m squared. And that would be our final answer for number 7. All right, so let's look at number 8. Number 8 is kind of a challenge problem. It's kind of taking some things we did in the last chapter, and we're going to apply it to this as well. So it says, write an equation that represents the measure of the area of the shaded region in factored form. So basically we're going to do what we did in chapter 6, the area of the shaded region, but then when we write it for our final answer, we're going to write it in factored form. So we're going to be looking to see what the GCF is so that we can take it out. So remember we learned that to find the area of the shaded region, we were going to do the big rectangle. That means this whole rectangle right here. All right. Then we're going to subtract the small rectangle. That's the white one on the inside. And that together is going to give us what we want, which is the shaded region. So that's our plan of action. We want to do the big rectangle minus the small rectangle, and that's going to equal the shaded region. So let's just talk about one thing at a time, and let's start with the big rectangle. So we need to know length and width, right? Because remember, area of rectangles is going to be length times width. So let's take a look at our picture. All right, if we want to find all the way across, we know from here to here is 5. Then from here to here tells us it's y. And then from here to here is another 5. So to go all the way across from the left to the right, I have 5, then I have y in the middle, and then I have 5 over here, and I'm going to add those together. So I'm going to end up with y plus 10, right? Because the 5 and the 5 are like terms. I can add them together. That's going to give you all the way across. Now let's talk about going up and down. From here to here, again, is 5. From here to here is x. That's what it says over here. And from here to here is 5. So I have 5 at the top, x in the middle, 5 at the bottom. So I'm adding those together, and that gets me x plus 10. So what we have for the big rectangle, for length times width, my length is y plus 10. My width is x plus 10. Now you may notice that in a moment we're going to have to do FOIL. Remember we learned that in the last chapter. So this is our length times our width. That's where that comes from. Now let's take a look at the small rectangle. The small rectangle is exactly what it says it is. The length is y, the width is x. So we're going to do y times x. That's the length times the width. And we have a subtraction sign there. And that's going to give us what we want, which again, I'm just writing it as the shaded region. All right, let's come back up to here where we have to FOIL. So remember, FOIL stands for first, outer, inner, last. So first, we're going to do the first term from each set of parentheses. So y times x is just yx. Then outer, we have to multiply the two outer terms. So we're going to multiply y times 10. So I'm going to write that as 10y. Then inner, we're going to multiply the two that are on the innermost parts of the parentheses. So 10 times x, which I'm just going to write that as 10x. And then last, we're going to do the last term from each set of parentheses. So 10 times 10 is going to multiply to give us a 100. And then here we had y times x, which I'm just going to write as yx. And again, that's going to give us our shaded region. All right, so let's look and see if we have any like terms. And we do. We have a yx here minus a yx here. Those two things are going to cancel each other out. So we have 10y plus 10x plus 100 is our shaded region. Now this would be a good answer for chapter 6, but now that we're in chapter 7, it wants us to take it a step further and write it into factored form, which is what we were practicing today. So we have to look for a GCF and see how we can rewrite that. So let's take a look at each factor. We have 10y, 10x, and 100. Now some of you guys can probably already tell what the GCF is, but I'm going to go through this process just in case. So 10y would break down into 2 times 5 times y. 10x would break down into 2 times 5 times x. 100 would break down into 2 times 2 times 5 times 5. So we want to look for what all three of them have in common. We have a group of 2's and we have a group of 5's, and that means that our GCF is 10. Now if you can tell that the GCF is 10, then you don't need to go through this work right here. I'm okay if you can see that, but I do want to make sure that you're finding the correct GCF. So we're going to take 10 out. Well, what's left from the first term when you take out a 10? All you have left is a y. Then I'm going to bring down my plus sign. What's left from the middle term when you take out a 10? All that's left is an x. Then I'm going to bring down my other plus sign. And then in the last one, what's left when you take out a 10? Remember, we're dividing it out. We're taking out the 2, we're taking out the 5 using division. What's left? A 2 and a 5, which gives us 10. And so this right here is going to be the answer for that. That is the area of the shaded region in factored form. So we did what we did in chapter 6. None of that part was new. All of that is a review. The only thing that we did extra was we took it one step further. We found the GCF and we took it out. So we wrote it in factored form. Remember again, factored just means you're trying to figure out what times what equals your answer. There is one more problem. And if you'd like to try it, it's kind of a challenge problem. If you want to try it, you can. It will be included in the work on the notes. I'm not going to include it on the video, but it's definitely a good one to practice your math skills. And I will see you guys for the next video. Bye.